Good evening, everyone. So, welcome to our discussion of today's test. So, we have 60 questions, but I will choose a specific number of questions out of the 60, the ones that are the ones that students are more likely to find hard, or the ones that usually are from topics that students struggle with. So some questions are from vectors and kinematics, which we had covered in last class, so I will not spend too much time on them. So I'll start with a few questions on projectile motion. So let's start with question number 2. So a particle is projected at an angle of 45 degrees. What is the relation between range and maximum height? So it helps to know a set of formulae for projectile motion. So there are some formulae that everyone, I think, remembers usually. So one is for range. Range is u square sine 2 theta divided by g. Maximum height is u square sine square theta by 2g. And the time of flight is 2u sine theta by g. So here we are given the value of theta. So r would be, if you plug in theta is 45, 2 theta becomes 90, sine 90 is 1. So r is u square by g. And h is u square sine square theta. So sine 45 is 1 by root 2. So sine square 45 becomes 2. Right. So comparing, you can see that r is equal to 4 times h. So I hope this is clear. Could you show the comments, please? Okay. Alright. So if there are doubts, please let me know in the comment section, or if there are specific questions you want me to do, let me know that as well. Okay. So next, let's look at the 6th question. The trajectory of a projectile is given, the equation for the trajectory is given. From the equation, we have to find out initial velocity of the projectile. Okay, so let's try that out. Okay, so if you remember the formula for equation of the trajectory, we can use that to solve this. But I would like to do this in a slightly different way. So look at the formula expression given to you. This is the equation of the parabolic trajectory. So we all know that for projectile motion, we have a parabolic trajectory. Okay. Now, to find the angle of projection theta, recall that the slope of a curve at any point is equal to derivative at that point. So I differentiate the function dy by dx, and I get 1 minus 4 by 5 x. Okay. And at x equal to 0, I'll get the slope is equal to, dy by dx is the slope, so putting x equal to 0, I get slope equal to 1. So if slope is 1, that means tan theta is 1, that is theta is 45 degrees. Okay, so we found out the initial angle of projection. Now we can also find the range easily. So from the equation, you see, if I take x common, I get x into x minus, x into 1 minus 2 by 5x. Okay. Now we can use this to find the range. So this polynomial on the right, it has two roots. One is x equal to 0, or x is equal to 5 by 2. So x equal to 0 is the point of projection. X equal to 5 by 2 will be the range. Okay. So we can find the we have the range now. We can find u by using this equation. U square sine 2 theta by g is equal to 5 by 2. Therefore, we can solve this. Theta we already found out is 45, so u square is 5 by 2g, and g is 10, so u turns out to be 5 meters per second. This is clear. So next, let's look at some problems from dynamics. Okay, so let's look at the 17th question. This is a conceptual question. Okay, so a student attempts to pull himself up by tugging on his hair. Okay, he will not succeed because. Okay, so out of the 4 reasons, which of the following reasons is the right one? And I consider this conceptually a very important question, right? So the first one, the force exerted is small. Well, even if that is true, that has nothing to do with it. Again, frictional force is small. No. Newton's law of inertia is not applicable. That's also not true. Some part of the question is missing. Newton's law of inertia is not applicable to living beings, I think. This is what was there in the question paper. It's applicable for everything, any physical object it's applicable to. The last one is the answer. The force applied is internal to the system. So internal forces cannot move the center of mass of a system. In other words, an internal force cannot pull a person, which is, obvious, because otherwise we could just push ourselves and go wherever we want to go. Okay. All right. Next, let's look at the 18th question. So you have a horizontally stretched net. The section AB, which is this section over here, is stretched with a force of 10 newtons. So here I have a force of 10 newtons. You are asked to find the tension in section BC and BF. So BC is this section, BF is this section. Okay. Now one assumption that we make is that the tension is only non-zero in the boundaries of the net. Okay. So even though there are chords inside the net, they are usually loose. They are not under tension. So with that assumption, we will make sure that we are not assigning forces anywhere other than the boundary line. So now, given that the net it's just stretched, right? It's not moving. So if I consider this point here, the net force on that point should be 0. Now, you can immediately answer the question just by using some common sense. If the resultant force is 0, notice that there is symmetry in this situation. If I draw the forces here, one force is like this, another force is like this, another force is like this. And this is 10 newtons. And these two forces are arranged symmetrically. What that means is it's like a mirror image. Whatever is on the left is an image of what's on the right. So from this symmetry, we can conclude that these two forces have to be equal. Why would they be different? Right? If there is symmetry, if whatever is on the left looks exactly like whatever is on the right, the forces should be equal. Right? The only answer that respects this symmetry is option C. Okay. There's also option D, which says cannot calculate due to insufficient data. That's not correct, because you can, given 3 vectors and the angle between them, you can always find you can always write the equation for the resultant and find out all the individual forces, right? Okay. So if you want to calculate, like we got the answer by elimination, but if we want to calculate, what do? Well, we have to resolve the forces. So I'll resolve the forces along horizontal and vertical direction. So this is F2. Now the whole angle is 120 degrees, so this would be 30 degrees. So you get F2 cos 30, just root 3 by 2. And here you get F1 cos 30, which is also root 3 by 2. Okay. And immediately you realize, just by looking at horizontal components, that F1 should be equal to F2, because they should cancel out, right? So if they cancel out, root 3 by 2 cancels out, F1 should be equal to F2. That is exactly what we concluded from symmetry in one shot. Okay. Next we look at the vertical components. So here, now that we know that they are equal, I'll just call them F. So one component will be F sine 30. Okay, sine 30 is 1 by 2. So I get F into 1 by 2. And the other one also has the same component. So 2 into F into 1 by 2. So equating the vertical components, 2 and 2 cancels out. F must be equal to 10 newtons. Right, so we found the answer in using just one trick and also doing it, solving it exactly. All right. Next, okay, so let's look at the 22nd question. The 22nd and 23rd question follow the same concept. So I'll focus only on the 22nd one. 3 concurrent coplanar forces 1, 2 and 3 acting along different directions on a body can keep the body in equilibrium if they act on a certain angle. The first and second is about some angle, and they mention one is they cannot keep it in equilibrium, etc. Now here is the idea. For 3 forces to keep an object in equilibrium, they should cancel out. In other words, the vector sum of the 3 forces must be 0, right? Now how do you add vectors? Like if you have more than 2 vectors, so if we have more than 2 vectors, how do we add them? So we join them head to tail, right? If you have one vector, this is one vector, this is another vector, this is another vector, f1, f2, f3. You connect the first tail to the last head, and that's how you find the resultant when you have more than one vector, right? If the resultant is to be 0, that means the 3 vectors should form a triangle, correct? Which means if the resultant is 0, if one vector is like this, the second one is like this, the third one should be like this. Okay. So that when you join the first tail to the final head, there's nothing, it's just a 0 vector. Okay. It's just a 0 vector. So now here we have this condition, I hope you remember from geometry, there is the triangle inequality which says if you have a triangle, sum of 2 sides should be greater than the third side. So if you have 1, 2 and 3, if I add 1 and 2, I get 3, which is not greater than the third side. So if it's equal to, you cannot have a triangle like this. If it's equal to, then the triangle becomes, it has an area of 0. Okay. In other words, it will not be acting in different directions. I hope this is clear. Okay. So same thing, we can look at the next question quickly. Which of the following groups of forces could be in equilibrium? Well, let's check for the triangle law. Okay, so here, if you add 2 forces, is it greater than the third force? We have to look at all possible combinations, and it turns out that it is true. Okay. So thankfully we are done. The first one is the correct one. We need not check others, but you can just see, just to understand the concept. Look at this. If I add the first two, 4 plus 5, it's 9, which is less than 10. Right? That cannot happen, violates the triangle rule. And here also 30 plus 40 is 70, less than 80. That violates the triangle rule. This one also, 1 plus 3 is 5, which is less than 1 plus 3 is 4, which is less than 5. Okay? So triangle rule again is not valid. It's not working here. So A is the correct answer. Okay? So moving on. Now this one is a slightly challenging problem. 2 rectangular blocks of masses 2 and 3 kg. So let's write that here. 2 kg, 3 kg are connected by a spring of constant 10.8 Newton per meter placed on frictionless horizontal surface. The block A is given an initial velocity of 0.15 meters per second. What is the maximum compression of the spring? Now, important thing to remember is both the blocks lie on a frictionless plane. They lie on a frictionless plane, which means if the spring compresses, the second block will also begin to move. Right? Because if the spring compresses, it pushes on the second block and there is no friction to prevent it from moving. So both the blocks will move here. That makes the problem appear a bit complicated. But what we do is, to solve problems like this, we look at the entire system. We look at the system as a whole. Look at the system as a whole, and we analyze the momentum and the energy of the system as a whole, and write equations for them. Okay. So let's look at momentum first. Now notice, in this entire system, there are no external forces. There is no friction. In the horizontal direction, there are no external forces at all. The only force, spring force, is an internal force. Now, if there are no external forces on a system, then momentum should be conserved. Okay. So let me write the equation for conservation of momentum. So change in momentum is 0, and that implies initial momentum, which was 2 kg into 0.15, must be equal to final momentum. Now, when I write the final momentum, how do I know the velocity of the two masses? The two masses could have different velocities. But look at what we are asked. We are asked the maximum compression in the spring. This is what we care about. Now think about it. When the compression in the spring is maximum, both the objects should have the same velocity. When the compression in the spring is maximum, both the masses should have the same velocity. How do we realize this? Let's pretend they don't have the same velocity. Okay, let's pretend for a moment VA is greater than VB. Now if VA is greater than VB, what is going to happen? A is going to get closer to B. So if VA is greater than VB, that means in the next moment, the spring is going to be more compressed. So if VA is greater than VB, it cannot be maximum compression. There is still some more compression left. Okay. Now what if it was the other way around? If VA was less than VB, if VA is less than VB, what's going to happen? That means they are going to get farther away in the next instant. If they get farther away in the next instant, that means the spring is, it's expanding at this instant. Right? So if it is expanding, that means at the previous instant, it would have been more compressed than it was right now. Okay? It's a subtle concept, but it's very useful in work energy problems. So we understand that it has to be, the two velocities have to be equal, and I'll call this as V. Okay? And we realize that just by thinking, what if they were not equal? We realize if they weren't equal, then it can't be maximum compression. There's still some compression left, or there was some more compression in the past. Okay, so since they have same velocity now, we have a total system of 5 kg moving with some velocity v, and we can find out v right away. So v is 2 into 0.15 divided by 5, so that is 0.06 meters per second. Okay. Next, we can use energy conservation. So initial kinetic energy, so this is energy conservation, delta is 0. So initial kinetic energy, which is half into 2 into 0.15 square, finally is converted into two kinds of energy. One is the kinetic energy of the total system, because the two blocks are still moving, right? So they have a kinetic energy, and whatever remains goes as the potential energy of the spring, half kx square. K is 10.8 into x square. Okay. So if you solve this, you will get C as the answer. So I'm not solving it because it's just obviously one equation and one variable. You can solve it now. Okay. But I hope the concept is clear. Right? Use momentum conservation, energy conservation. Use the fact that the spring is at maximum compression to realize that the velocities are equal, and then just solving the equations, you'll get the answer. Right. Okay. Next, let's look at the 26th question. In the figure, the energy E and VC and velocity of center of mass are given. Mass of the object is given to be 1 kilogram. Okay. Right. So Prajwal seems to like the triangle inequality. Yeah. So it's very interesting how, geometry pops up quite often in physics. People often think of physics as mostly algebraic equation manipulating. But we must remind ourselves that occasionally thinking geometrically really helps solve the problem much quicker. Okay? Thinking geometrically, thinking graphically, etc. Right. So they mentioned that E represents the total energy. Now, usually we think of total energy as kinetic plus potential, right? But here we have to kind of understand from the problem that it can't be potential, because we don't know what kind of potential could be there if it is there. Is it gravitational potential? Is it spring potential? So since nothing else is mentioned in detail, we assume that what they mean by total energy is total kinetic energy. Okay? Because when you have a rolling object, it has two kinetic energies. One is kinetic energy of translation plus kinetic energy of rotation. Okay, so this is kinetic energy corresponding to motion of center of mass, and this is kinetic energy corresponding to rotation around center of mass. Okay, now they have given a graph for this, and they have asked us to find what kind of an object is it. Out of the four given ones, what kind of an object is it? Well, how do we know what kind of an object it is? Well, we have various expressions for moment of inertia. For a sphere it is 2 by 5 mr square. Ring it is mr square. For disk it is 1 by 2 mr square. And for hollow cylinder it is mr square. Okay. Well, if you're smart, you can immediately eliminate ring and hollow cylinder because both of them have the same moment of inertia. So either both of them should be correct or none of them should be correct. And both are not an option in this test, right? But anyways, so our job is to find out the moment of inertia, or at least to find the fraction that comes in front of the moment of inertia. Okay. All right. So let us try to work on that now. Okay. So I'll write the moment of inertia as some alpha into mr square, where alpha is that number, the half or 2 by 5 or whatever it is. Okay, if you find alpha, we are done. So half into alpha into mr square, and omega for pure rolling is equal to v by r, where r is the radius of the object. Okay, so for pure rolling, omega is v by r, so I get v square by r square cancels out. Therefore, I can take half m vc m square common, and I get 1 plus alpha. Okay. Alright, so now let us look at the graph. Let's look at the graph. So in the graph, you are given E versus Vc squared. So if you are given a Y versus X graph, right, the slope of the graph is what we call M, and that here will be everything other than V squared. I hope you see that. So a general straight line graph passing through the origin is of the form y is equal to mx, and the slope of the graph is what we identify as m. So just making that comparison, okay, so the slope here must be half m into 1 plus alpha. Okay. I hope that's clear. Slope is half m v square. Oh yeah, half m into 1 plus alpha. So in the graph, that half m into 1 plus alpha, the slope is opposite by hypotenuse tan of this. Sorry, opposite by adjacent. So that is 3 by 4. Okay, and m is given to be 1. So we can solve for alpha, and it will turn out to be alpha will turn out to be 1 by 2. So this is a nice question. So this is clear. Okay. Next, we look at a conceptual question, a very important conceptual question. Two particles which are initially at rest move towards each other under the action of the mutual attraction. If the speeds are v and 2v at some instant in time, what is the speed of the center of mass? Well, again, once we realize that the force is entirely due to mutual attraction, we realize that external force is 0. And if the external force is 0, then the center of mass should not accelerate. Okay. Now, since the particles are initially at rest, and since we realize that the center of mass shouldn't accelerate, therefore the center of mass should remain at rest. So the speed of the center of mass is 0. Okay. It's a simple question if you're familiar with the concept, but it's very important. Okay. Not just from an exam point of view, but if this were not true, we would be in great trouble, because every time you have a system of particles, right? Anything you see is a system of particles, a human being or a pulley mass system, whatever it is a system of particles. So the fact that only external forces can move the center of mass allows us to forget about all the internal forces that are there. So if you're looking at the motion of a human being, you only care about the external forces. You don't care about the forces between cells or molecules or whatever it is. Okay, so Aditya is asking a question. It is acceleration that is 0. How do we know that velocity is 0? Good point. Okay. So if external force is 0, it is the acceleration that is 0, but it is also given that the initial velocity of the particles is 0. Okay. If initial velocity of both particles is 0, what will velocity of the center of mass initially be? Remember, the formula for velocity of center of mass is summation mi vi divided by summation mi. Okay. Now if all the particles are at rest, center of mass also will be at rest. Okay. So initial velocity of center of mass is 0, and in addition to that, acceleration of center of mass is also 0. So if initial velocity is 0, acceleration is 0, then final velocity should also be 0 at any time. Okay, I hope you follow. So very good point. If this was not mentioned that initially they were at rest, we cannot answer this question. Okay, all right. Now let's use the formula that I gave you earlier to find the answer to the 32nd question. A system consists of 3 particles, each of mass m, located at points. So the masses are given, points are given. What is the coordinates of center of mass? Okay. So let me move this to a different page. Okay. This is a straightforward computation actually, but let's just recollect the formula. So xcm, x component of center of mass, is summation mixi by summation mi. Okay, and here we have 3 particles. So I take the mass of each particle, m into the x coordinate of first one plus m into x coordinate of second one plus m into x coordinate of third one, divided by sum of all the masses, which is 3m. So the m cancels out and I get 1 plus 2 plus 3 by 3, which is 2. Okay. And ycm would be 1 plus, let's do the same thing again, it's the same formula, summation mi yi by summation mi. So again m will cancel out and I'll get the same thing, 1 plus 2 plus 3 divided by 3, and again I get 2 as the answer. Okay. So the answer therefore will be 2, 2. This is straightforward formula application. Alright, let's now try another nice conceptual question. Okay, 34th question. A particle is moving uniformly along a straight line as shown in the figure. During the motion of the particle from A to B, this is A, this is B, what happens to the angular momentum of the particle about O? Okay, there are very tempting options. I'll give you the most tempting one. First increases and then decreases. Oh, all right. I think a more tempting option would have been first decreases and then increases. Okay. So see, if we are not very careful, we will take this formula for angular momentum, L is equal to mvr, and we'll think about it. Okay. What I'm about to do is the wrong answer. Okay. But you have to understand why it is wrong. Okay. So as the particle moves, we will think, oh, initially the particle was far away from the origin. Okay, O is the origin, and now it's getting closer, and at some point it's very close, then it goes far away again. So if we are not careful, we will think R first decreases, then increases. And thankfully that's not there in the options, but then we will say, okay, m is constant, v is constant, but R is doing this, so angular momentum also first decreases, then it increases. But that is wrong. Okay. So the reason that is wrong is this formula L equal to mvr is not always correct. It's actually a special version of the original formula. The original formula for L is L is equal to R cross P. It's a vector formula. R is a vector, P is a vector, L is a vector, right? So the magnitude of L will be Rp sine theta. Okay. So this can be written as P into R sine theta. And if you try to interpret R sine theta, what is it? Think about it, right? So if I choose some random R, and I have the angle between P and wait, let me choose an angle over the other side, that's easier. So I'll choose a random R like this. This is my R vector. The particle is going from A to B, so this is the direction of my P vector. Yeah, so I think the other side is better. Okay, both are fine actually, but other side will be less confusing, I feel. Okay, so P is this way, R is this way, the angle between R and P will be theta. And now look at what R sine theta means. R sine theta is basically this distance, the perpendicular distance of the point of the line along which the point is moving from the origin. Okay. Alright. There is another suggestion. You can just use conservation of angular momentum. I'll also talk about that. That's the dynamical way of thinking about it. This is a very definition based way of thinking about it. Thanks for that suggestion. Okay. Alright. So one way is just by the definition you realize that R sine theta is remaining constant. So you have to keep this in mind. In our formula, L is equal to mvr. R is not just the distance but the perpendicular distance from the axis, the point that you consider your axis. And the perpendicular distance remains the same. Okay. Alright, so the answer is it remains constant. Now let's look at Aditya's answer, which is also very nice. So he's suggesting, since the particle is moving uniformly along a straight line, the net force acting on it must be zero. Right? Uniform motion means acceleration is zero, force is zero. Now if the force is zero, torque should also be zero. If torque is zero, then angular momentum is conserved. There's a nice flow of logic. But keep in mind, conservation of angular momentum works only if the net torque is zero. Okay, which is true in this case. So you can just say by conservation of angular momentum, the angular momentum must remain constant. Yeah. Thanks, Aditya. Very nice. Okay. Now let's look at the 37th question. So this, in one question you learn two important expressions, two important formulae regarding moment of inertia. So you are given the moment of inertia of a circular disc and of mass 1 kg, radius 2 meters, about an axis passing through the center perpendicular to the plane. So you have an axis, you have to imagine perpendicular to the plane of the screen, passing through the center. Okay, that moment of inertia is given. That is 2 kilogram meter square. Okay. Now we have to find the moment of inertia about an axis, this axis parallel to the axis but passing through the edge. Now first what we do is we find moment of inertia about the axis xy shown in figure here. Okay. So it's kind of unfair because you are given a hint in the question itself. It shouldn't be there. Okay. So you find the moment of inertia about xy first. How do you do that? You use perpendicular axis theorem. So consider another axis through the center. So you have two axes perpendicular to each other lying on a plane, and then you know the moment of inertia about the other axis. Now perpendicular axis theorem tells you if you have any planar shape and you have moment of inertia about two perpendicular axes, then you can find the moment of inertia about an axis perpendicular to both of these by just adding the two moments of inertia. Okay. So using that here, I can argue that Ixy plus the other axis I'll call x prime y prime, Ixy plus Ix prime y prime must be 2. Okay, I hope it's clear. This axis plus this axis, moment of inertia is 2. Now notice both those axes are symmetric, they are identical actually. With respect to our system here, both the axes are diameters of the circle, right? So therefore these two moments of inertia must be equal, and therefore you get Ixy is equal to 1. Because they are equal, you get 2 by 2, which is 1 kilogram meter squared. Next, I use parallel axis theorem. So what does parallel axis theorem tell you? Ix1 y1 will be I about center of mass axis plus mr square, where r is the shift from center of mass axis. Okay. So we found out I through center of mass axis right now, because Ixy is through the center of mass axis. This is the center of mass, the center of the circle. Okay. So I get 1 plus mr square. M is 1 kg, r is 2 meters. So we get 4. Okay. So from? Let me just check quickly. Moment of inertia is 2 meters. Perpendicular is 2. So each of them will end up being 1, and 1 plus 1 into r square is 5. Okay, so I guess the options were not entirely correct. Let me just make sure that I am not wrong. So x, y. Okay. Yeah, I guess the options are not entirely correct. Okay. So the concepts are completely fine, I believe. So we'll just take a look at the options and see if we can make a correction. Alright. Next, let's look at the 44th question. Okay. So a rubber band is stretched by a distance x, it exerts a restoring force where A and B are constants. Work done in stretching the rubber band by L. Alright. So this is basically just the definition of work done. We have to apply the definition. So what is the definition of work done? Work done is integral f dot dr. This is the definition. Okay. Now since this is a one-dimensional problem, there is only x here, so we need not worry about other components. So we just write f dx. Okay. Now what is f? F is ax plus bx square. So we have to integrate this with respect to x. And this unstretched rubber band we are stretching it by L. That means we are going from 0 to L. X is going from 0 to L. So it's just a straightforward integral. You get AL square by 2 plus BL cube by 3. Okay, just integrating. So the answer is C. Next. Okay, let's look at the 56th question. A time-dependent force acts on a mass of a particle of mass 1 kg. Particle starts from rest. What is the work done by the force during the first second? Well, so yeah, this is also a nice question. So I'll solve that over here. 56th one. So F is equal to 60. You have to find out the work done. Now, work done is integral f dx. In the previous question we solved, f was given as a function of x and we could integrate easily. But in this problem, f is given as a function of t. Excuse me. F is given as a function of t. So how can we integrate it? If I write integral 6t dx, we can't integrate. There's one variable here, another variable here. So we solve this problem indirectly, not by evaluating work done directly, but we use a theorem that we have derived, a result that work done is change in kinetic energy. Okay, so if we just find final kinetic energy minus initial kinetic energy, our job is done. We would have indirectly found out the work done. Okay, that's what we'll do here. Okay, so let's look at the given data. It starts from rest, so u is equal to 0. Force is given, so we can find acceleration. Acceleration is also 60. Okay, now we can find velocity. How do we find velocity? Velocity is integral a dt, integral of acceleration from 0 to time t. The time t is given to be 1 second here, so that turns out to be integral 60 dt from 0 to 1. So you get 6 into t square by 2, substituting 6 into 1 by 2, which is 3 meters per second. So plugging that into my expression here, I get half into 1 into 3 square, which is 9 by 2, 4.5 joules. Okay. I hope you follow. So when the force is given as a function of x, you integrate it directly. When the force is given as a function of t, you use work energy theorem to solve it. Okay. All right. So let's look at the 57th one. Now this is a bit more challenging. So in this question, the force is given as a function of velocity, different from both the previous questions, right? So what do we do now? Force is given as a function of velocity. Well, let's think about what's asked, right? Its initial speed is v naught, and after 10 seconds its energy is 1 by 8 mv naught squared. Okay, so let's find out what the final velocity is. We are given the final energy. See, initial energy would have been half mv naught squared. Final energy is 1 by 8 mv naught squared. We can write this as half m v naught by 2 the whole square. Correct? So we realize by comparing with the kinetic energy formula, we realize that the velocity has gone from v naught to v naught by 2. This is expected because force is negative. We will expect the speed to decrease. Okay. So basically the question is asking, in 10 seconds, if the speed has decreased from v naught to v naught by 2, which is 10 meters per second to 5 meters per second, what is the value of k? Right? So we need not actually use energy or work here. We can directly use Newton's laws. So we have F is equal to minus kV squared. Now what is F? F is m dv by dt is equal to minus kV squared. Okay. Now we can move things around. I can write on the left side I collect terms having v, and on the right side minus k by m dt. This is called separation of variables. This is a way of solving differential equations. You might have learned it in math. Okay. Now we will integrate both sides. Integral dv by v squared. Now velocity goes from 10 to 5, and on the right side k and m are constants. Minus k by m integral dt. T goes from 0 to 10. This is given in 10 seconds. Okay. So if you do this integral, you end up getting, you can try it yourself, but what you will get is k by m on the right side 10, and on the left side you get 1 by 5 minus 1 by 10. Okay. You can actually do it quickly, but if you can't, try it at home later. So 1 by 5 minus 1 by 10 is k by m into 10. So solving this, you can find, substituting for m, you can find the value of k. It turns out to be 10 power minus 4. 10 power minus 4 kilogram per meter. Okay, so this might have been the longest problem in the test, which would have taken most of your time. Others are very simple. There's a question, I kind of missed it. In a system of mass, if one particle exerting a small force accelerates for a long period of time, will the force add up and do we get motion of the body? Okay, so I'll answer that question, and I'll also answer another question. Someone is asking me to try question 7. Okay. Right. Sure, so I can do question 7. Let me look at your comment. In a system of masses, if one particle exerting a small force, one small particle exerting small force accelerates for a long period of time, will the force add up and do we get motion of the body? I'm not clear what is causing the force. The thing is, if you have a system of masses, and if the force on each mass is coming from another mass inside the system, okay, so like this, okay, I'll just find some space. Okay, so imagine you have a bunch of particles, around 7 particles here, 1, 2, 3, 4, 5, 6, 7, okay, and you are thinking of these 7 particles together as your system, and if, like you said, there's one particle having a small force, okay, let's say there's a small force on this particle 1 for a large period of time. Now, where is this force coming from is very important. If the force is coming from another particle within the system, okay, then the center of mass will not move. It cannot move. No matter how long you wait, the center of mass will not move. But if the force is coming from outside the system, let's say someone from outside is attracting this, then the center of mass will move. Okay. I hope that answered your question. Okay, it's not an issue of the size of the force. It's like, oh, small force, large force, will it change? It's not an issue of amount of time also. If the forces are internal to the system, center of mass will not move. Okay, and if you want a reason that is slightly intuitive, if you're thinking, why is it not moving even though I waited for a long time? Because you see, if the force is coming from another particle, right? Let's say the force is coming from particle number 7. Particle 1 is attracted by particle number 7. Now Newton's third law says that particle 7 will also be attracted by particle 1. So what will happen? Particle 1 will move, agreed. If you wait for a long time, particle 1 will move. But particle 7 will move in the opposite direction. And as a result of that, the center of mass motion will be 0. It will be, the motion of the two will compensate. Okay. Again, assuming what Aditya earlier asked, assuming initially everything was at rest. Okay. If initially the center of mass was at rest, it will remain at rest. Okay, so I hope I answered your question. Right, so Aditya is asking, so if in explosion center of mass doesn't move. So in explosion center of mass doesn't move, right? So center of mass doesn't move if initially the center of mass was at rest, even later the center of mass will remain at rest. Okay, but initially if center of mass was moving, even after the explosion it will continue to move. Okay, right. So I'll move on to question number 7. Okay. Right. Copy. Okay. Let's look at the given info. So force is given to you, initial velocity is given, and you are asked something about the final velocity. Okay. Now from force we can find acceleration. Acceleration is force divided by mass. Okay. Acceleration is force divided by mass. So that gives you minus 3 by 5 I cap plus 4 by 5 j cap. Okay. And initial velocity, they called it V, I'll call it U because that's our standard naming. Okay, is 6 I cap minus 2 j cap. Now the time after which it will have a velocity along y-axis. So if the velocity is along y-axis, you want the final velocity to be only along the y-axis, that means we want its x component to be 0. Okay, y component could be anything, we don't care. Okay, plus vy you could call it. Okay, we don't care about this. All we care is that the x component should be 0. So now the idea is here, in the kinematic equations, you have various kinematic equations, right? V is equal to u plus at, s equal to ut plus half at square. These two equations actually are also valid in their vector form. V is equal to u vector plus acceleration vector into t. S vector is, one second, there is no 2 here, I'm sorry. V is equal to u vector plus a vector into t. S is equal to ut plus half at square. You see, these are all vectors now, except time, everything else is a vector. The third equation remains the same. V square minus u square is equal to 2as. Here these are magnitudes. Okay, and here what you take is the dot product. That's the third equation. So these are the vector forms of the three kinematic equations. Okay, note the difference in the third one. Right. Okay, so therefore what can you say? For each component you can write your familiar kinematic equations. Vx is equal to ux plus axt. Right? Now here our final x velocity is 0, initial x velocity is 6, acceleration in the x direction is minus 3 by 5, and we have to find out time. Okay, so rearranging we get t is 10 seconds. Verify that. Right, t is 10 seconds. Is this clear, Prajwal? Yeah. Okay. If there are any other doubts, again let me know. If not, I'll move on to the graph questions. Now, these are quite important. These are most definitely asked in standard competitive exams. At least one question about interpreting graphs, not one, more than one will come. pretty certain. Okay, all right. So you are given the graph of f versus x. You have to find work done in displacing the particle from x equal to 1 to 5 meters. So first thing is we mark the range that we care about. Okay, we only care about 1 to 5. The interval that we care about is just this much, from 1 to 5. We can neglect everything else. Okay. Next, we realize that f dot dx or f dx integral is work done, and integral is area under the graph of f versus x. So we just find the area under the graph, and to do that we divide it into pieces. Okay, so the first piece here is a rectangle. Its area is base is 1, height is 10, so it's 10. Second piece is also a rectangle, base is 1, height is 5, so it's 5. Third piece is a rectangle, also minus 5. Areas under the x-axis contribute with the minus sign. This is a triangle, base is 5, height is 10. So triangle formula gives me 5, half into base into height. Okay, this 5 and minus 5 cancels out, so the final result is 15 joules. Okay, here this is fine. So a very similar question. Again, you are asked to find the work done in covering an initial distance of 20 meters. Okay, initial distance of 20 meters means 0 to 20. So again, I mark the interval 0 to 20. Okay, and I have to find the area under the graph to find work done. Okay, that's the whole concept here. So I'll again divide it into pieces like this. Okay, so the first piece is a triangle. Half into 5 into 10 gives me 25 units as the area. Second piece is a rectangle, base is 10, height is 10, so that's 100 units. Third piece also is a rectangle, base is 5, height is 10, 50 units. Next piece is a triangle, base is 5, height is 10, so you get 25. Okay, so the total area is 25 plus 25, 50 plus 50, 100 plus 100, 200. Okay, so I hope that's also clear. Okay, now in the last 7 minutes that we have, since some of you were asking questions about explosions, etc., I think we'll solve a problem on explosions. Let's solve the 54th question. A shell of mass 20 kilograms explodes initially at rest, explodes into two fragments whose masses are in the ratio 2:3. The smaller fragment moves with a velocity of 6 meters per second. What is the kinetic energy of the larger fragment? Okay, so let's try that out. Okay, so the important thing is to notice that this is quite important. Initially at rest. Okay, we have to be careful about that. If initially it was moving, then the solution will change. Okay, all right, so let us first draw a figure to understand this. So you have a shell, total mass was 20 kilograms. It breaks into two fragments whose masses are 2:3. Okay, breaks into two fragments, 2:3. So how do we divide a 20 into a ratio 2:3? So I divide by 5, so first is 8, the second one is 12. Okay, so 8 kg and 12 kg. Now this is in the ratio 2:3. 8 kg, 12 kg. I hope you are okay with ratios because it's simple math. Now the smaller fragment moves with a velocity of 6 meters per second. The larger fragment, we have to find its velocity. So we just use conservation of momentum again, because explosion is entirely due to internal forces. Momentum has to be conserved. Center of mass has to remain at rest. Okay, all right. So initial momentum was 0 because initially it was at rest, and final momentum is for the 8 kg mass into velocity. So 8 into minus 6. If I take right to be positive, it will be 8 into minus 6 plus 12 into the unknown velocity, which I will call v. Okay, now this can be solved, and you get v is equal to 8 into 6 divided by 12. So you get 4 meters per second. Okay, and its kinetic energy is half mv square, so it's half into its mass is 12 kg into 16, 6 into 16, which is 96, yeah, 96 joules. The answer is 96. Okay. Alright. So maybe we'll solve one more question involving collisions. Let's do the 53rd one. So we're just trying to cover the various topics, not the entire test. Okay. So a body of mass 5 kg is moving with a velocity of 10 meters per second, collides with another body. So first thing I do is draw a figure. Okay, this will be very helpful. 5 kg, 20 kg, and I write their velocities. The 5 kg mass is moving with so initial velocity of the 5 kg was 10 meters per second, and initial velocity of the 20 kg 0. It was at rest. Okay. Now we have to find the final velocity of the second body due to the collision. Right. So we'll call the final velocities as v1 and v2. This v1 is given to us, it's 0, it comes to rest, it's given. So we have to find out v2. So now we just have one variable, and now we know that in collisions there is one thing that's always conserved. So one thing that you might be worried about, it's not mentioned whether it's elastic or inelastic. But the thing is, regardless of whether it's elastic or inelastic, momentum conservation always holds. So using momentum conservation, initial momentum is 5 into 10 plus 0 for the other mass. Final momentum is 5 into 0 plus 20 into v2. So solving, I get v2 is equal to 5 into 10 by 20, which is 2.5 meters per second. So I hope this is clear. The collision could be inelastic. We need not even worry about it, right? Because momentum conservation always holds for a collision. Okay. Right. So with this question, I think we'll stop. Now next, your chemistry test will be discussed from 6 to 7 p.m. Thank you.
Good evening, students. My name is Venkat. In fact, I'm a HOD in CFAL. I'm going to discuss CET question paper which you have appeared today. Students, are you all ready? Good evening, Rachel. Good evening, everyone. Okay, students, you all knew there are free CET test series and paper discussion every day. Every day there will be 2 tests, either part or full test. Full schedule is mentioned in our website cfalindia.com. In the evening, both papers will be discussed here live in YouTube. Okay, students. Next, we will start with our question paper. So the first question: which one of the following orders presents the correct sequence of the increasing basic nature of the given oxides? You all knew metallic oxides are basic. Increasing order of basic nature, if they ask which is more metallic, that oxide is more basic. So if you see, first group elements are more metallic. In that, while going down, metallic nature increases. So potassium is more metallic, so its oxide is more basic. Next one, sodium, magnesium, aluminum 13 group. So metallic nature decreases from potassium to aluminum. So the D is the right answer. D is the right answer. Here, periodic classification and properties, chemical bonding, metallurgy. In that, chemical bonding is very, very important, students. Every year 3 to 4 questions they are asking. Minimum 2 questions they will give. Next one, first ionization potential of sodium, magnesium, aluminum and silicon are in the order. You know, across the period ionization energy increases. Across the period ionization energy increases. There are some exceptions. If element is having stable configuration means half filled or completely filled atomic orbitals. If it is having half filled or completely filled atomic orbitals, that configuration is more stable. Removal of electron from that element is difficult. So there are some exceptions. If you see, sodium, magnesium, aluminum, silicon, these are third period elements. In case of magnesium, there is an exception because it is having 1s2, 2s2, 2p6, 3s2 configuration. So here we have to remove electron from s orbital and it is completely filled. In case of aluminum, you have to remove electron from p. So penetration power of s orbital is more. So s electron is more. It requires more energy. So there is exception here. Sodium, magnesium is not this option. So magnesium is having more ionization energy than aluminum. So the option is A. Option is A. Which of the following oxides is amphoteric in character? This one also important, students. There are basic oxides, acidic oxide. Basic oxides, I already told you how to decide. Acidic oxides, non-metallic oxides are acidic in nature. Apart from acidic and basic, there are amphoteric oxides. If you want, I will give SnO2, PbO, Al2O3, ZnO. These are the main amphoteric oxides. Still there are amphoteric oxides. If they ask neutral oxides, carbon monoxide, nitrous oxide, nitric oxide. These are neutral types of oxides. These are the amphoteric oxides. So here SnO2 is the amphoteric oxide. Can you see, students, now? Okay, next one. Successive ionization energies of an element M are 176, 346 and 1850 kilocalories. Formula of its sulfate. Okay, students, like these questions, if they give IE1, IE2, IE3, they have given IE1, IE2, IE3. Just observe where sudden jump happened. Here 176 to 346, almost doubled. 346 to 1850. There is a here there is much difference in energy. Much difference in energy. When we get sudden jump, students, if we are removing electron from stable electronic configuration, that time only ionization energy suddenly increases. So where you are observing sudden jump in ionization energy, that electrons here, first electron to second electron, after getting 2 units of positive charge, means after removing 2 electrons will get +2 charge, right? Removal of third electron is difficult, means after losing second electron it got stability. So its valency is 2. It is ready to lose 2 electrons. This particular element M is ready to lose 2 electrons, so its valency is 2. And its sulfate formula they ask, sulfate or sulfite, both valency is same, 2. So here MSO4. Same question, student, same, not same question, same model. Can you tell fifth question answer, students? Fifth question. So here this is IE1, IE2, IE3 and fourth ionization energy. IE1, IE2, IE3 there. Shiva, how we know it is 2? See here, from M you remove 1 electron, that time charge is +1. So here ionization energy is 176. Okay, from this unipositive ion, if you remove 1 more electron, so this element will get +2. So that here ionization energy is 346. Now third ionization energy means you are removing electron from dipositive ion. So to remove this electron, removal of electron from dipositive ion requires more ionization energy, more energy. Okay, so if you are using more energy, means here it is in stable condition. So +2 is the stable oxidation state of the given M, element M. So right, valency is nothing but number of electrons shared or number of electrons transferred. Okay, 2. So here if you observe from IE3 to IE4 there is a sudden jump in ionization energy. Okay, thank you, Shiva. So its stable oxidation state is +3. Its stable oxidation state is +3. Okay, 1, 2, 3 after removing third electron. So valency of the element is 3:2, not 4. That's well. It is 3 because removal of fourth electron from +3 is difficult. Means +3 state is stable. Means it is ready to lose 3 electron. That is only its valency. That. Next one. Sixth question. Can you try, students? electron affinity they are asking. What is electron affinity? Energy released when an electron is added to the outermost shell of isolated gaseous atom. So here energy is releasing. Now in electron affinity there is exception. Electronegativity is different. Electron affinity is no Shiva. Electron affinity it is all it won't be always proportional to electronegativity, because electronegativity is the tendency. Electron affinity is energy. Tendency of accepting pair of electrons is called electronegativity. Energy released when an electron is added to outermost shell in gaseous state is called electron affinity. Here what you know, oxygen and sulfur, if you take, oxygen size is small, it has good tendency to attract electrons, but there is no sufficient what we say accommodation capacity. Sulfur, next element sulfur, it is having enough tendency to attract pair of electron. At the same time, because of empty d orbitals, it can accommodate more electrons. So sulfur electron affinity is greater than selenium, oxygen. Same trend, same reason in case of selenium also. Some students they are writing sulfur next oxygen, and this is not correct order, students. Sulfur, selenium, oxygen. If you want in NCERT also, they have given values. Go through this. Many students are doing mistake. Sulfur, very next to sulfur, oxygen they are writing. It happens only in halogens, not in 16th group elements. Sulfur, selenium, oxygen. Clear, students? In case of sulfur, there are two favorable factors. One is it is having enough tendency to attract electron. At the same time, it is having more accommodation power because of empty d orbitals. In oxygen 2p, only 2p orbital one is available. In case of sulfur, since it belongs to third period, there are 3d orbitals, empty 3d orbitals. That's what Prajwal I said. Selenium is not more electronegative than oxygen. It is having enough electronegativity to attract electrons, but it is having more accommodation power. I will give one general example. I started one institution. It is having very good name, but is very small. Many students are ready to join in my institute, but I can't provide accommodation for many students, so I won't get more money. One more person by observing this, he started a very big institution, but no name. Even he won't get. Third person, by observing these two, he started one institute which is having enough accommodation capacity and it is having enough name. Means somewhat not better than mine. So that time third person can gain more money than first one and second one, isn't it? Here accommodation capacity is also matter, not only name. Here name is nothing but tendency. Tendency is there, but it can't provide. I want to grab more admissions, but no accommodation. So that is the reason. In that sulfur and selenium case also same reason we can apply. Prajwal, is it clear? Okay. Next one. And dipole moment applications are also important, students. BF3 and NF3 both molecules are covalent. They are having MX3 type structure only. But BF3 is non-polar and NF3 is polar. What is the reason? Both are having MX3 type structure. BF3 is polar, non-polar. NF3 is, whereas NF3 is polar. What is the reason? So here dipole polarity and non-polarity not only, it depends on not only polar bonds, it depends on symmetrical structure. If in structure symmetry is there, overall dipole moment, overall polarity will be equal to 0. See, BF3 since in BF3 central atom undergoes sp2 hybridization, I'll wait students, here I'll draw the structures of NF3 and BF3. Okay, BF3, here in BF3 central atom boron undergoes sp2 hybridization, no lone pair of electrons, so its shape is triangular planar, symmetrical in all the directions, so polarity is the direction. In case of NF3, nitrogen is undergoing sp3 hybridization and there is one lone pair. You know, for sp3 hybridized molecule, regular geometry is tetrahedral. Since there is one lone pair, shape is pyramidal. Here polarity is like this. There is a resultant polarity, but here net polarity will be cancelled. So it is non-polar. Here dipole moment is not equal to 0. So in BF3 there is a polarity. Next one, 8th question. If HCl molecule is completely polarized, so expected value of dipole moment is 6.12 but experimental value of dipole moment is 1.03. Calculate the percentage ionic character. So in CET maximum formula based problems only they ask students most of the questions. So formulas, prepare one book, formula book. So here percentage of ionic character is equal to experimental value of dipole moment is equal to experimental value of dipole moment by expected value of dipole moment. Expected value of dipole moment into 100. So here experimental how much they have given? 1.03. Units anyway same, no need to convert. 6 point expected how much? 6.12 into 100. So around 16.83% you will get, which is close to 17. Option is A. Experimental means after doing experiment they get. Theoretical we will calculate. Both they will give in exam. No, calculated sometime what you know. Dipole moment formula. Shiva. Dipole moment formula is equal to magnitude of charge into distance of separation of charges. Distance of separation of charges. Sometimes what you know, bond length and distance, charge they will give. So this, from this whatever we calculate, no, that is called calculated or expected. Experimental they will give. Clear? So 1.03 upon 6.12 into 100. Next one, which of the following has high polarizing power? Which of the following has high polarizing power? Polarizing power depends on size. If size is small, polarizing power is more. Polarizing power is inversely proportional to size. Polarizing power is inversely proportional to size of cation. Directly proportional to size of anion, students. Next one more is magnitude of charge. Polarizing power is directly proportional to magnitude of charge. See students, since aluminum is carrying higher charge, it is having more polarizing power. And polarizing power is directly proportional to covalent character, students. Polarizing power is directly proportional to covalent character. Which is more covalent if they ask? Suppose here PCl3, PCl5. Which is more covalent if they ask? Go for oxidation state. Central atom in PCl3 gets +3 oxidation state. In PCl5 gets +5 oxidation state. So this charge is more, it is having more covalent character. Clear, students? Next one. Which is more ionic, which is more covalent, like that they are asking. Among the lithium chloride, RbCl, beryllium chloride, MgCl2. The compounds with the greatest and least ionic character respectively. You know Poisson's rules. To give priority to which in the last. Prajwal, I didn't get you. When to give priority? Let me send once again. Okay, here Poisson's rules. I'll explain here. BeCl2, MgCl2, CaCl2, something RbCl. Now they have given. In this, beryllium size is too small. According to Poisson, covalent character is inversely proportional to size of cation. Note down these points, students. Size of cation. Covalent character is with respect to anionic size, if you see, directly proportional to anionic size. Directly proportional to anionic size. And third factor is directly proportional to magnitude of charge. Magnitude of charge. Okay, now keep these 3 points in mind. We'll go to solve that problem. One is covalent character is directly proportional to anionic size, inversely proportional to size of cation, magnitude of charge. This lithium size is small, beryllium size is also small. Out of lithium and beryllium, polarizing power, so it is inversely proportional to size of cation and directly proportional to magnitude of charge. These both which to give priority. You will come to know if it is a very small element, its polarizing power is more. Generally they differentiate by charge or size. Charge or size, for that you no need to worry. Now here if you see this question you can understand. Lithium and beryllium, here charge is there, the time for size will give priority. So they ask greatest ionic character and least ionic character. First greatest ionic character will decide. Among all, if you compare first group and second group elements, first group elements are first group elements can form more ionic the ionic nature of first group elements more. So here rubidium chloride we can take, and least if you see beryllium chloride. Here size is high, size is small, charge is high. So two factors are favorable. So option is B. Students, if you have any doubts you can ask, and in answer key also if any doubts you can ask. Greatest ionic character, here also respectively they asked ionic character should be first, least ionic character, highest ionic character should be first, least ionic character should be next. So RbCl and BeCl2. Next, correct order of bond length is. Correct order of bond length is. Here bond length is inversely proportional to bond order. You all knew bond length is inversely proportional to bond order. So if you know bond order of these compounds, we can decide which is having more bond length, which is having. CO bond order through molecular orbital theory. This I am going to explain how to find out the bond order. Since it is having 14 electrons, carbon 6, oxygen contain 8 electrons, so total 14 electrons, so its bond order is 3. In CO2 you know CO bond order is 2. So out of CO2 and CO, which is having highest bond order? CO. So it is having least bond length, CO2. Next CO3 2 minus, CO3 2 minus, it's like this. It forms resonating structures. So total 3 resonating structures are possible. So how to find out bond order in case of resonating molecule, students? Total number of bonds, total number of 1, 2, 3, 4 by total number of resonating structures. Around 1.3 you will get. So CO bond order is 3, CO2 bond order is 2, this one is 1.3. So here bond order is less, bond length is more. Next, this is the decreasing order of bond length. Understood, students? Here molecular orbital theory you have to apply, structure based. Here CO2 is structure based or valency based. CO3 2 minus through it can form resonating structures. In case of resonating molecules which can form resonating structures, bond order can be calculated by using the formula total number of bonds formed by the central atom upon total number of resonating structures. So option is A. Next, in which of the following pairs the two molecules have the identical bond order? So to find out bond order, students, I will tell you one simple technique. Instead of writing molecular orbital theory, the molecular orbital energy order and all, and up to 14 electrons, above 14 electrons, there are different 2 different orders. Instead of that, since you won't get much time in CET, this order you follow from 10 electrons up to 9 electrons easily you can find out. 10, 11, 12, 13, 14, 15, 16, 17. So here molecular orbital theory applicable up to 18 electrons. So if these are the number of electrons in the molecules. Bond order is equal to 1. The contestant. From here 0.5 increase, 2, 2.5, 3, again up to 3 increase, again decrease by 0.5, 2, 1.5 and 1, up to 3 increase, again decrease. Okay, next, even magnetic nature also you can write easily. Magnetic nature, 12, 14, 18 electron systems are only diamagnetic. 12, 14, 18 electron systems are only diamagnetic. Rest all are paramagnetic only. So this one is diamagnetic, 14 electrons diamagnetic and 18 electrons, so diamagnetic. Rest all are paramagnetic. Paramagnetic. So you can decide like this instead of writing. Clear, students? Bond order is easy. 0.5, 0.5 increase up to 3. Afterwards again decrease. 0.5, 0.5. Magnetic nature also I told. Now we'll go to the question. Molecular orbital theory applications are also important, students. Easy and important. Don't leave it. So here nitrogen total number of electrons 14. O2 2 plus, if you count 16 minus 2 plus 2 is, then it lost 2 electrons. So here 14 electrons. So no need to go for other options. They are having same number of electrons. And sometimes, students, if number of electrons are not same also, bond order can be same. Here if you see 12, total number of electrons, if it is equal to 12, bond order is 2. If it is 16 also, total number is equal to 16 also, bond order is 2. If two bond orders are same, then how to decide which is more stable, which is having less number of, here no exceptions, Shiva, no exceptions. Which is having more number of anti-bonding electrons, that is less stable. Bond order is directly proportional to stability, we will tell. Sometimes bond order will be same, where N2 minus N2 plus. N2 plus how many electrons? 13 electrons. N2 minus 15 electrons. Both molecules bond order is same, 2.5, 2.5. In that case, which is having more number of anti-bonding electrons, that is less stable. Which is having less number of anti-bonding electrons, that is more stable. Next, this question is important for p block elements also. Of the following hydrides, which has the lowest boiling point? Here boiling point depends on two factors. One is intermolecular hydrogen bonding, another one is molecular weight. Intermolecular hydrogen bonding and molecular weight. If you see which factor we have to apply first. There are three elements mainly: fluorine, oxygen, nitrogen. They are more electronegative elements. In that, fluorine is highest electronegative element, oxygen is second most electronegative element, nitrogen is third most electronegative element. So fluorine can form effective intermolecular hydrogen bonding. In that case, irrespective of molecular weight, intermolecular hydrogen bonding only you take. Consider. Second case also H2O also, but in case of NH3, intermolecular hydrogen bonding compared to molecular weight of BiH3, SbH3, intermolecular hydrogen bonding factor plays less role. So their molecular weight factor plays major role. So what is the correct order? BiH3, it is having high molecular weight, so its boiling point is more. Next one, SbH3. Next, in between NH3 because of intermolecular hydrogen bonding. Next, ASH3. Last one is PH3. Which has lowest boiling point? They ask PH3. Suppose if you take 16 group elements hydrides, since oxygen is more electronegative, it can form effective intermolecular hydrogen bonding. This time hydrogen bonding plays major role. That factor dominates. So H2O comes first position. Rest of the order same: H2TE, Here molecular weight you follow. H2Se, H2S. Same thing follow in case of hydrides of 17th group elements also. HF comes first, afterwards HI, HBr, HCl. Their lowest boiling point molecule is hydride is HCl. HCl. Here H2S. In 15th group elements PH3. Hope you understood, students, this one. 16th, 17th, 18th hydrides. In case of hydrides, you have to prepare thermal stability, boiling point order, reducing nature. Based on the nature of the compounds you prepare. If the hydride category, you have to follow these things. Reducing nature, thermal stability. Thermal stability, how it changes, students? In case of hydrides, as the bond length increases, bond strength decreases, so thermal stability decreases down the group. H2O, H2S, H2 Se, H2Ta. You see down the group, OH bond length is increasing, so bond strength decreases. Reducing nature also follows the same. Reducing nature is opposite to that. I'll explain it at the end. Or P block, while explaining P block, I'll give full clarity about hydrides, oxides, how to prepare. Next, number of sigma bonds in P4O10. So for this you have to draw the structure. P4O10 structure is like this. So here 6 over oxygen, double bond O, double bond O, double bond O. This is the structure of two phosphorus atoms connecting with the oxygen in case. Upon each phosphorus, double bond O if you keep, you will get the structure P4O10. Now, how many sigma bonds are there? If you count, you will get 16, students. Count. 16 bonds you will get. Which molecule is not linear? Which molecule is not linear? BeF2. BeF2, what is the hybridization, students? BeF2, BeH2, CO2, H2O. Here hybridization of BeF2 is sp, because beryllium has 2 valence electrons. 2 valence electrons can form 2 bonds with fluorine. So if the total number of number of sigma bonds, if you count 2, you will get. I hope you know this method, students. I'll introduce how to find out hybridization in a simple way. If they ask hybridization of any molecule, first central atom valence electrons, you take number of valence electrons. Beryllium, since it belongs to second group, has 2 valence electrons. These 2 valence electrons will form 2 bonds with the fluorine. Since they are single bonds, both are sigma bonds only. If total number of sigma bonds, even lone pairs are included in hybridization. If total number of sigma and lone pairs is equal to 2, sp hybridization. If it is equal to 3, sp2 hybridization. 4, sp3. 5, sp3d. 6, sp3d2. 7, sp3d3. sp3d3. Okay, now total number of no lone pairs, 2 sigma bonds are there, so its hybridization is sp. Next, one more BH2 they have given. Same. Since hydrogen is also monovalent, we will get 2 bonds, sp hybridization only. One more CO2. So here carbon valency 4. Since it belongs to 14th group, its valency, number of valence electrons is equal to 4. Here oxygen valency 2. So it can form 2 bonds with the 2 electrons at a time. Here one more oxygen also can form 2 bonds. Here if element forms multiple bonds. In that, one is sigma bond, another one is pi bond. If it is triple bond, one is sigma bond, rest two are pi bonds only. Okay. Now here also I told you only number of lone pairs and sigma bonds including hybridization, not pi bonds. Pi bonds are not going to affect the geometry of molecule. Okay. So here also sp hybridization. Last one, H2O. These four molecules they have to be. Here central atom is oxygen. So it belongs to 16th group. So 6 valence electrons you have to take. 3, 4, 5, 6. 2 hydrogens can form 2 bonds. Now count students. 1, 2 sigma bonds plus 2 lone pairs. The sum is equal to 4. So which hybridization it is? sp3. sp3, and there are 2 lone pairs. According to Vesper theory, VSEPR theory, presence of lone pair of electrons distorts the geometry of molecule. So sp3 hybridized molecule structure must be tetrahedral because of 2 lone pairs. Geometry started to V shape or angular shape. They asked which is not linear. This is not linear. So H2O is the correct answer. Hope you understood how to find out hybridization. And if they ask shapes also, students, Vesper theory, that chart is there, go through once. Lone pair of electrons. And in case of sp3d hybridization, this is the point you keep in mind. According to Bend's rule, you are not supposed to keep lone pair of electrons on axial positions. There are 2 types of bonds, trigonal, bipyramidal, equatorial bonds and axial bonds. In axial positions, you are not supposed to keep lone pair of electrons. That condition you follow. So H2O we got. H2O is the correct answer. Clear, students? Next one, pair of compounds having identical shapes for their molecules is. The pair of compounds having identical shapes for their molecule is CH4. If you take sp3, same method you apply, students. sp3 hybridization you will get. SF4, you can count on fingers also. Sulfur belongs to 16th group, so it has 6 valence electrons. 4 fluorines can form 4 bonds. So 4 electrons are involving in bond formation. Only 1 pair is left, that is lone pair. So 4 sigma bonds and 1 lone pair. Total 5. sp3d hybridization. sp3d hybridization. Since there is 1 lone pair, has distorted tetrahedral. So these 2 are not having identical shapes. So this option you can eliminate. Next one, actually it should be BeCl2, not BCl2. Boron can form trichloride. So it is linear. And this one ClF3. Chlorine belongs to 17th group. So it has 7 valence electrons. 7 valence electron. 3 fluorines can form 3 bonds. 3 fluorines can form 3 bonds. Out of 7 valence electron, 3 are forming bonds. So 3 sigma bonds, and the 4 electrons will make 2 lone pairs. sp3d hybridization. So I will draw the structure. This one I will explain. ClF3. 7 valence electrons. Take 7 valence. 1, 2, 3, 4, 5, 6, 7. 3 fluorines can form 3 bonds and we get 2 lone pairs. 3 sigma bonds plus 2 lone pairs is equal to 5 sp3d hybridization. sp3d regular geometry is trigonal bipyramidal. Yes, trigonal bipyramidal. I told you, no, don't keep lone pairs on axial position. One more lone pair. This is T shape. T shape. Like this, you can find out the shapes of molecule from original geometry. If one more lone pair is there, here we will keep. So linear. sp3d, one lone pair, distorted tetrahedral. It is also called seesaw shape. If it is having 2 lone pairs, T shape. If it is having 3 lone pairs, linear. So the distortion chart you follow. It is important for p block elements also. Next, metallurgy students. The ore that is concentrated by froth flotation processes. So in metallurgy, you have to know the names of the ores and the formulas. Froth flotation technique is used for the concentration of sulfide ores. So in the given options, which is sulfide ore, you have to know. Bauxite, it is oxide ore, Al2O3. Malachite, copper ore, it is not sulfide ore. Next one, zincite, ZnO. Next one, cinnabar is the ore of mercury. Its formula is mercuric sulfide. If you know Brajwell, it is cinnabar, mercuric sulfide. Cinnabar is the ore of. Sometimes they are asking like this: cinnabar is the ore of. Among the following, which is sulfide ore, which is oxide ore, carbonate ores, like that they are asking. Next important question: copper matte, Ce2S FeS. Next one, cassiterite is the ore of which metal? Tin, SnO2. It is the oxide ore, cassiterite. No, it is not manganese. Cassiterite is the ore of manganese. Next one, in surface process, byproduct obtained in the purification of bauxite is. First of all, what is surface process? Surface process is used for bauxite ore if it contains silica as major impurity. If it contains silica as major impurity, surface process. So here what we are using, okay, in surface process, Al2O3 coke plus nitrogen we are adding. See here, carbon will take oxygen from aluminium oxide, so CO will form, students. Here aluminium combines with nitrogen form aluminium nitride. It happens in first step. In aluminium nitride, on further hydrolysis. So here what is the basic principle? Nitrogen selectively react with aluminium, not with silica, which is impurity in this. So it extract aluminium from the impurities. Impurities will be left over there only. Now on hydrolysis, nitrides on hydrolysis, we get respective metal hydroxides and ammonia, students. So aluminium metal is there, no, aluminium hydroxide, it is a precipitate, and ammonia. So in the next step, aluminium hydroxide, if you heat, you get Al2O3. So impurities will be left here only. Impurities will be left here only. Still, if silica is there, carbon monoxide, on heating will be removed. Here more than 1400, 1500 degrees we are using temperature. In that temperature silicon will be vaporized. In that way we can remove silica. So what they asked question, what is the byproduct formed in surface process? Byproduct formed in surface process is NH3. Next two more processes are there, students. Hall's process and Bayer's process. Hall's process, Bayer's process can be applied for both impurities. Both impurities are present. You can apply Hall's process and Bayer's process. Surface process is mainly to remove silica. If ore contains silica as main impurity, they may ask like this: if ore contains silica as major impurity, which method can be used? Surface. So option is NH3. Almost similar model. Which one of the following ore is best concentrated by flotation method? Arena. Since formula is PBS, lead sulfide. KCET right, already I told you. Magnetite, iron oxide ore. Metallurgy, copper ore. Basic, copper carbonate. So A is the correct answer, Projectile correct answer. Next one, this is leaching process, students. Silver ore plus cyanide in aqueous medium in the presence of oxygen gives X. X on reaction with, here we will get one soluble complex, which on reaction with zinc it forms Y. They are asking X and Y. So silver can form bi-coordinated complex with cyanide, students. AgCN2 minus. Here zinc, why we are using? To displace silver from the soluble complex. So what we get? ZnCN4 2 minus plus Ag. What is the correct answer? A. No, silver silver cannot form tetra coordinated. Clear, students? Which of the following give respective metal by self reduction? There are different reduction process, students. Some oxides can be reduced by hydrogen, some oxides can be reduced by carbon, some oxides can be reduced by carbon monoxide, but some ores, they undergo self reduction, no need to use any reducing agent. Those I'll give the list of those elements: mercury, lead, copper, etc. These mainly undergo self reduction. Sulfur, I think in the NCERT, copper they have given. Not only copper, mercury and lead also undergo self reduction. So option is lead sulfide, mercuric sulfide, both A and B. D is the correct option. How they undergo, you know. Suppose HGS on oxidation gives HGO plus SO2. HGO reacted is there, no? It react with again HGS, forms 3Hg plus SO2. Same thing happens in other cases also. Element used as semiconductor or purified by. You have to use best process to refine these elements. What is the best process? Zone refining. Zone refining is used to refine semiconductors. Next, tell me students which process it is. In JEE mains also they are asking these simple questions. Mond's process is used for. In Mond's process, which compound is used to form soluble complex? Now, titanium plus iodine, it is forming TiI4. It is a soluble complex. Impurities will be left here. It is a soluble complex. Next, again if you heat, iodine will be left, pure titanium will get. This is called Van Erkel process. Very good, Shiva, correct answer. If it is nickel, we use Mond's process. For that, here iodine we are using, no, there carbon monoxide will use. So while selecting the compound, it has to form volatile complex, means less stable complex it has to form. If it forms more stable complex, separation will be difficult. No use. So which can form soluble complex and which can form fusible complex. Little if you heat, it has to decompose. If it retains with the compound, no meaning of purity or purification only. Which of the following statements is or are incorrect? Cuprite, and so my suggestion is students, just some important ores list you prepare. Cuprite and zincite, both are oxide ores only, C2 and ZnO. Azurite and chalcopyrites are the ores of copper. Yes, CuFeS2, chalcopyrite ore, azurite ore, CuOH twice, 2 CuOH twice, CuCO3, basic copper carbonate ore. So both are this one is correct, this one is correct. Magnesite and carnallite are carbonate ores. No, magnesite is carbonate ore only, but carnallite, KCl, MgCl2, 6H2O. So it is halide ore, not carbonate ore. So it is incorrect statement. Fluorspar and mica minerals contain aluminium. No, fluorspar formula is CaF2. Mica contain aluminium. So 3 and 4 statements are incorrect. Next one, silver and gold are often obtained as a valuable byproduct during. Electrolytic refining, anode mud. Have you heard? Electrolytic refining of copper. Anode mud at near anode mud will form. That contains silver and gold. That extraction is highly expensive, so you won't extract. So electrolytic refining. Okay, students. So time up. Maximum questions we try to do. Okay, students. Bye bye. See you tomorrow. Same time. Thank you, students.